Today we're going to be talking about dividing the same base, which is the quotient of powers property. The objective or objectives for today is that by the end of this video, you should be able to divide two of the same base. To help us better understand today's objective, I've got a series of questions for you. First one asks us, what is 5 divided by 5? Well, 5 divided by 5 is 1, because when you divide any quantity by itself, you get the number 1. What about 12 divided by 12? So again, dividing 12 by itself means we get 1. What about this really large number divided by itself? Well, again, you get 1. The whole point of this, again, is to lead you up to a concept or an idea, because we're about to divide two of the same letter. What is x divided by x? The answer is 1, because you're dividing x by itself. What about x to the 9th over x to the 9th? Again, the answer is 1, because you're dividing x to the 9th by itself. The next question I have for you is that if you multiply two of the same base, it means that you add the exponents. So what do you suppose dividing two of the same base will do? Go ahead and think about that question. And then also, I would like you to expand out the following to see what happens when we divide. So we're going to do x to the 9th over x to the 4th. By expand, I mean write x times itself 9 times and x times itself 4 times on the bottom. So multiplying means you add the exponents, then dividing means you should subtract the exponents. I went ahead and expanded out the bottom two expressions, and we're going to use the property we just got through learning a little while ago to help us answer the question, what is x to the 9th over x to the 4th? Well, x over x, we can rewrite that as 1 times x over x would be 1 times x over x, 1 times x over x, 1 times, and I have 1, 2, 3, 4, 5 different x's left over. Leaving me with 1 times 1 times 1 times 1, which is just 1. X times x times x times x times x, which is x to the 5th. Y'all, anytime you have a coefficient of 1, you don't have to write it. We can just write it as x to the 5th because there's just one x to the 5th there. Let's look at the next one. X to the 7th over x to the 3rd. Maybe you could guess it. 7 minus 3 should give us x to the 4th. So again, when you divide the same base, this process I went through in the middle is not necessary. When you divide two of the same base, all you have to do is subtract the exponents. 7 minus 3 is 4. 9 minus 4 is 5. In the following, I have a series of questions we're going to work through to help us better understand this property as it shows up in a variety of ways. Let's take a look at that first expression. X to the 7th, y z to the 8th, over x to the 6th, z to the 5th. Again, just like what we did when we were doing multiplying the same base, when we divide the same bases, we look for the pairs. X to the 7th over x to the 6th is going to give me x to the 7 minus 6, or x to the 1st. Y over, there's nothing to divide y by, so it just says y. Z to the 8th, z to the 5th becomes z to the 8 minus 5, or z to the 3rd. The next one, x 10th over x 3rd is x to the 7th. Y 4th, y squared is y to the 4 minus 2, or y squared. What about x to the 4th over x? Remember, your exponent is 1 if it's not listed, so it's x to the 4 minus 1, or x to the 3rd. Y to the 12th, y to the 5th. 12 minus 5 is 7, so it gives me y to the 7. X to the 5th over, well, there's no other x, so we just write it. X to the 5th. y7 over y to the 3rd gives us y to the 4th. because 7 minus 3 is 4. Y to the 9th over x to the 4th, which you can't quite see yet. For y to the 9th over x to the 4th, notice that the bases are different, so we cannot simplify any further. Why? Well, the reason again is that the bases are the same. Last question of this group is x to the 5th over x. What would that be? Again, the exponent of x is 1, if there's not an exponent listed, so it becomes x to the 5 minus 1, or x to the 4th. So let's go ahead and summarize what we just got through doing in the previous two videos. In the first video, when we multiplied two of the same bases, emphasis that the bases have to be the same, you add the exponents. When you divide two of the same bases, you subtract the exponents. So a real quick recap, x to the 11th times x to the 5th should give you x to the 16th, whereas x to the 11th over x to the 5th gives you x to the 11 minus 5, or x to the 6th. We're going to go ahead and take a look at a couple of examples. We have about 5 more total for the video. Let's look at the first 3. What I'd like you to do is to see if you can, on your own, work out these problems. They're going to be a little bit different from the ones we've seen to help extend your knowledge. Please pause the video, try working them out, and when you're ready to see the answer, please press play. Okay, for the first one, again I'm going to pair it up. X to the 8th over x squared gives me x to the 6th, because 8 minus 2 is 6. y5, y3rd gives me y to the 5 minus 3, or y squared. Hoping, based on the previous examples, you could have done that first part. The confusing part is, what do you do with z over z? Well, that takes us way back to the beginning of the video. Z over z divides to give us a 1. So we're left with x to the 6th times y squared times 1. Anytime you multiply anything by 1, you get the original value, giving us x to the 6th y squared. You don't have to write the times 1 if you do not want to. So you try the second example. If you got the first one a little mixed up, it's okay. Try to work out the second example and press play when you're ready to see the answer. Hopefully you got x to the 7th. The y's canceled out to give you times 1, since they had the same exponents, times z to the 2 minus 1, or z to the 1st. We could simplify that further, because multiplying y1 does not actually change the value of the x or the z, giving us just x to the 7th, z to the 1st, or just z. Last example, and we've got 2 more after this. Last example of this segment is x to the 8th, x to the 6th over x to the 3rd. Y'all, when you have this type of example right here, it's a good idea to multiply the ones on top that you can first, leaving us with x to the 14th, because 8 plus 6 is 14, over x to the 3rd. Then we can apply the subtraction rule. 14 minus 3 is 11, leaving us with x to the 11th. I've got 2 more examples after these for you to try. When you see them, please press pause, work out the problems, and when you're ready to see the answers, please press play. Alright, let's go ahead and look at those last 2 examples. Again, you should try these on your own. first one, remember that you simplify the tops first. So it gives us x to the 9th times x to the 4th. 9 plus 4 is 13. Y to the 3rd. Over xy squared. Then we can apply the division rule. 13 minus 1 is 12. 3 minus 2 is y to the 1st, or just y. Again, you do not need to write an exponent of 1. Let's look at the next example. Notice it has a coefficient, actually two of them, a 12 and a 3. Anytime that happens, you just go ahead and divide the 12 and the 3. But first, let's simplify the tops and the bottoms. 12 x squared x5 gives us x to the 7th, y to the 9th, over 3, there's an x again, is x to the 7th, y squared y third gives us y to the 5th. We can now apply the division rule, which 12 over 3 is just 4, but x7 over x7 is 1, y9 over y5 gives us y to the 4th. We do not need to write 4 times 1, because 4 times 1 is just 4, y to the 4th. And there is your last example for